What's up everyone? It's Mr. Lang. In this video I'm going to teach you how to factor trinomials that are in disguise. Sounds very mysterious, but I'm telling you it's not. So let's get started. Alright, for degree 2 trinomials, the general form is ax squared plus bx plus c, where this a, b, and c just represent numbers. Alright, so you could think of this like 2x squared plus 3x plus 9, something like that. That would be what this means. So with three terms like this, we learned that we could factor them using the 2 by 2 window and figuring out how all that works. Well, what if we have something like this? This is x squared minus 9. Now this looks like a binomial, and I will grant you that it actually is because there's only two terms. But it is actually a trinomial in disguise, and I'll show you how. Well, the x squared term, the ax squared, would just be the x squared, 1x squared. There is no bx term in this. There's nothing with just a plain x. So it goes right to the c, which is the negative 9. So if there is no bx term, you can think of it as a 0x. Because 0 times anything would just give you 0, and it would actually go away. So really, this x squared minus 9 is this trinomial in disguise with the 0x as the middle term. Well, we know if it's a trinomial of degree 2 like this, we can just use the 2 by 2 window to factor. We did that in class. So what I'm going to do, I've got my pre-made box here because it's kind of hard to draw boxes on the computer here that look at least somewhat neat. We know how to factor this. Alright, well, we put the x squared here because we know that's where that's going to go, and the negative 9 is going to go down here, and we know that we're going to have an x and an x here to get there. So, well, what x terms, because we know the x terms go here, are going to multiply to get to negative 9? Well, you could do 1 times a negative 9, something like this. We could try a negative 1 times positive 9. That would give us a negative 9. We could also have a 3 times a negative 3. That would also give us 9. So I'm going to start off by trying the 3 and the negative 3 here. And we're going to see why this is the one that works. Well, x times 3 is going to give me 3x. And x times negative 3 is going to give me negative 3x. And when we combine our like terms to kind of check this out, look at what happens. The 3x and the negative 3x give us that 0. So this is my factored form. It's going to be x plus 3 times x minus 3. That's my factored form of x squared minus 9. So even though this is a binomial, it's really a trinomial in disguise, and we can factor it like we would any of the normal trinomials. You're going to see that they kind of come out nice and neat like this. Now this only works when you have a subtraction, and you're going to see that this has got to be a perfect square, but we'll look. Let's try this one. This is x squared plus 9. And I'm already telling you this is not going to work, but I'm going to show you why. Alright, we're going to make it a trinomial that's in disguise. This looks almost exactly the same as the last example. The only difference is that this is plus 9 instead of minus 9. Well, oops, I've got my pre-made one. Alright. I use my pre-made square here. I'm going to put the x squared here. I'm going to put the positive 9 here. And I got my x and my x, I know that. It's going to give me my x squared. And I got to figure out, well, how do I get to 9 by multiplication? Well, it'll be 1 times 9 and 3 times 3. I could go negatives too, but I think we're going to see that that's not going to work for us. Let's try the 3 and the 3. If we tried the 3 and the 3, we'd get 3x here and 3x here. When I add these two together, I get 6x. Doesn't work. So I'm going to get rid of those two. All right, now I'm going to try the 1 and the 9. Well, I would get 9x here and a 1x here. And when I add these two up, again, I'm going to get 10x, not 0x. And it doesn't matter if I pick negatives with -1 and -9, -3, -3. It just flat out doesn't work. So this doesn't factor. And when something can't factor, we say it's prime. So listen, if you see one of these trinomials in disguise, but it's a plus, that ain't going to work. All right? It's got to be a minus, like we had in the first example there. All right. Third example. We got x squared minus 8. And this looks like a good candidate for a trinomial in disguise, but it's not going to work. All right, so I'll write it as my trinomial in disguise. So I'll put the plus 0x and then minus 8. I'm going to make my box, my window here. I've got an x squared here. I've got a -8 here. My x and my x, and I got to say, well, how can I get to -8 by multiplication? Well, I can just try a couple things here. I could try a 2 and a -4. That would give it to me. So I would multiply this out. It would be -4 times x would be -4x. 2 times x would give me 2x. They're not going to cancel each other out to 0. That's going to be a -2, right? So no good. Instead of 2 and -4, I can try, I don't know, 1 and a -8. But again, this is not going to cancel out to 0. This is going to be -7x, not plus 0x. So this can't factor either. And the reason is because this is not a perfect square. So this is prime. Can't factor it. It's just x squared minus 8. Can't factor it. All right. So let's kind of summarize everything that we've been doing here. So the first example we did was x squared minus 9. We could factor this for a couple reasons. First of all, it was subtraction. And both terms are perfect squares. So the x squared and the 9, the square root of 9 is 3. So the square root of x squared is also x. So both of these are perfect squares, and it's a minus. So we call this the difference of two squares. You'll sometimes hear it called by that, or dots as a kind of acronym, DOTS. Difference meaning subtraction. So x squared minus 9 we could factor. That worked out. The x squared plus 9 we could not factor. And even though it's almost the same thing, it's because it's a plus there. It just doesn't work. It's because it's addition. We could not factor that. And the third example we did was x squared minus 8. And we couldn't factor this one either. It was prime because both of these were not perfect squares. The x squared was fine. The minus was fine. But the 8 is not a perfect square. The square root of 8 is not an integer. All right. So I want to do just a couple examples here. These can go very quickly. All right. Example 1 is x squared minus 25. And I believe I can factor this because it's a minus and I've got two perfect squares. The square root of 25 is 5. So I'm going to have my x squared here. I'm going to have my negative 25 here. I'm going to have my x and my x. And I know the only way I'm going to get to the 0x in the middle where they cancel out is going to be a if I use a 5 here, well, I'll use a negative 5 here, and a 5. We're going to see why. Negative 5 times x is negative 5x, and x times 5 is 5x. These are going to cancel out to that 0x in the middle, so we're going to get x squared minus 25. So factored form would be x plus 5, x minus 5. Very similar with y squared minus 81. I can factor that one. 81 is a perfect square. I know that perfect square is going to be 9. So this has got to be a minus 9 and a plus 9. And we can check this out. 9 times y is 9y. Negative 9 times y is negative 9y. These are going to cancel out to 0, so we're going to be left with just y squared minus 81. So this is y plus 9, y minus 9. Trinomial in disguise, that's how we factor it. Two more real quick. We got a squared plus 36. It's a trinomial in disguise, but we got a problem here. That's a minus. I'm sorry, that's a plus. We want it to be a minus. So this is unfactorable. This is prime. Don't waste your time with it. And then example 4 is one like we didn't see yet. This is factorable. It's got a minus in the middle. 100, the square root of 100 we know is 10. In this, although it's not just n squared, it's 9n squared, this is a perfect square. If you took the square root of 9n squared, you'd get 3n. So let's see how this shakes out. So we got 9n squared minus 100. We know we're going to have a 3n here and a 3n here. Same term. So this is a perfect square. And the square root of 100 is 10. So I'll put a minus 10 here and a 10 here. Let's see how this shakes out. 3n times 10 is 30n. 3n times negative 10 is negative 30n. These two terms are going to cancel out to 0, leaving us with just 9n squared minus 100. So listen, factored form for this is going to be 3n plus 10, 3n minus 10. Alright, and what's nice about doing it with this window method, the check is already built in. You can just look at it and check it. Cool. Alright, let's get to the CYU questions. I've got 6 questions for you. I want you to factor them. Almost all of them factor, but there's at least 1 or 2 that don't. If it's not factorable, just write prime. Cool. So now we're getting into some heavy factoring here. So make sure one smart thing to do after you do these check your understanding questions is just read through your notes again. Every night that we take new notes or you do a video, read through your past notes again. It's going to help you keep everything straight in your head. All right, thanks for listening.